Hey guys, I'm going to be showing you the process of building this case for our wireless solar monitoring system, so let's go ahead and get started with that. Alright, so this is the case for the transmitter unit. I haven't knocked out the support material yet. Anyway, plenty of space in here, that's for sure. I could have probably shortened these wires up and made the case a little bit smaller, but I just went ahead and made the case to match the wire length that's already there, since I didn't really want to go and redo it. But I went ahead and printed this in green because, well, it's solar powered, it's supposed to be green, right? So let's see if we can get the support stuff out of here. And there we go. Doesn't even look like I have to do much cleanup on it. Actually, where that support material was came out really nice. I expected that to be all jagged and messed up, but it did a really good job with that. So anyway, the top of this, I put a little hole in here for an LED, and this just fits down inside there. A little bit loose, probably put a little bit too much space in there in the CAD software, but that's okay because I'm not really going to need to be inside of this once I get it put together. So hopefully the connector actually fits through here, and it does. Not quite perfectly set up there, but it'll do for our purposes. And then these connectors will just be glued in place, super glued in place. Alright, so I'm going to go ahead and wire in a power indicator LED for this. I don't really need one, but just seems like something that this should have. So anyway, actually I just did a little bit of 3D printer maintenance too, and these parts are coming out really nice. Or these two did. Seem a little nicer than normal. A lot of times I have issues with these parts cracking. I just assumed that was because it was ABS and it, you know, the different 3D printing this stuff contracts and expands, and I figured that was causing the cracks in it. But this time I printed the walls a little bit thicker, and this was actually printing infill on the inside of the wall too, so that might have made a little bit of a difference. But anyhow, parts actually came out pretty nice. And a couple of tips when it comes to 3D printed stuff: if you're designing the parts, you want to put a fillet on the inside edge, right where my finger's running across, all the way around the bottom. That increases the strength. And there's actually one on this too. It's not as big, but it's there. And also, just one of the things that I like to do is put a chamfer around this edge here, because that theoretically should make it easier to put together. But this one I made a little bit loose apparently, so I won't adjust for it. Usually with 3D printing, if you make the tolerances at 0, so this gap in here was, I think, 2.8 inches, and I made the gap across this about 2.76, I think it should have been 2.76, so they would go over into each other relatively easily, and it does work well enough. I mean, I can glue this one shut. I'm not gonna have to get into here at all. So anyway, I'll get a power indicator LED on there and get this thing put together. Alright, so now is the part that's always kind of a pain in the butt, and that's getting all these connectors to actually line up right and glue them in. So what I'm thinking I'm gonna do is just tack them in with hot glue and then come in with the super glue and get them down permanent. So grab a hot glue gun and see what I can do here. But the one thing I'm worried about is the solvent and the glue knocking the hot glue loose. So I guess we'll just have to see what happens. But while that heats up, I can get that LED glued in there. That is, if I can get the cap off of the glue, of course. Alright, so we'll go ahead and put a dab of glue on the LED, on the LED, since it's actually held in there reasonably well by the plastic. Alright, that should be good. Just had to make sure that this glue would actually work, because it seemed pretty plugged up. So anyway, hot glue gun should be heated up by now. bit in there. Alright, the connectors are glued in here. Go ahead and just let that sit for a few hours before I start messing with it anymore. But anyway, I got them stuck in there. We'll see how... for now, I only have glue on the top side of the connectors, so we'll see if that's actually strong enough to hold it, or if I'm going to have to get onto the bottom side of the connector somehow and glue it, because I don't want to put glue on the outside, so... Alright, so this is the front lid of the case for the transmitter unit here. Wanted to start with the lid this time because I'd like to put this down in it first and then get measurements on where everything else is supposed to be. So anyhow, I've got a big slot in this side for the USB port on the Arduino Nano here, because I figured that would cause some interference. This actually comes awful close to the switch too, but I think we'll be okay with that. The transmitter unit is still drying here, so there's not a whole lot left to do on this. I put some more glue on these to stiffen them up a bit more. I got some glue behind them, but anyhow, I'm probably gonna have to glue the circuit board down a little bit here, just a couple tacks of hot glue. So this one, we're going to have a big case with relatively not a whole lot in it. And then this one's going to be a relatively small case. It's just packed full of stuff. So anyway, the way this is designed, it should actually kind of fit in here tight, this LCD frame. So I'm just going to have that mounted pretty much flush. Of course, we're just going to glue stuff together and show you what it'll look like. I'll go this way. And you see the colors there look pretty good. So now, it would be a little bit more logical to have that power switch up on top here, but unfortunately, taking this off the back, there's so much stuff in the way, there's no real room to put that power switch there, so it's going to have to go on the side, I'm afraid. So it shouldn't be too hard to mount this LCD since I put these pin headers on everything. There's no real worries when you take stuff apart because the pin headers will just pull off, but I should be able to mount this just in here reasonably easy, flush mounted. and glued on the back side. And hot glue comes off easily enough, so I'm not too worried about it being stuck in here permanently. You see, it actually holds itself in there reasonably well, obviously. Not good enough to really hold it there permanently, but just run a line of this stuff along here. Should be plenty. Just let that dry, or harden, or whatever. Cool off, I suppose. And then we'll have the LCD mounted, and I'll start working on the design for the bottom part of this case. Alright, so a little bit of an update for you guys here. My printer has started to act up quite severely, and I can't get it to do anything useful at this point, so I'm going to have to figure out what the heck is going on with that. Anyway, I got to... the first time I tried printing the base for the receiver unit, I got this far into it. And looking back at the footage, the printer just completely stopped. And looking at the screen capture of it, there was an error that popped up saying USB device is malfunctioning or something like that. And then I tried to start it up again, and it only got about 5 minutes into it, and it stopped completely again. And that time, the cooling fan on the printer ramped way up, and then the there's no error that time on the computer. It actually stayed connected, but I'm getting brownout reset, which to me means power supply issues. But checking the voltages with all the heaters and stuff turned on, I've got like 13.5 volts coming out of the power supply or something that's probably way too high. But it's been running like that for quite a while. I actually manually went and turned it up because there wasn't enough power getting into the heated bed with all the cable losses. So I went ahead and I cranked that voltage up just a little bit. 13 volts is still within a reasonable level, especially considering once it got through the cabling to the printer, I think it's only like 12.5 or something like that because the voltage drop. It's kind of thin cabling, I think. It's warm anyway. But anyway, I give up on the printer for the day, but the glue has hardened on this thing. So last thing I'm going to do, we're going to glue this board in place. Just a little tack of glue. I still want to be able to get this out of here if I really have to. So, and hot glue is really easy to remove. If you guys don't know this trick, you can take a little bit of denatured alcohol, just a drop or two of it, and hot glue will just pop right off. It's really a nice trick that you can use on that. Works really well. And I'm going to hot glue this part here too. So I don't really know what's going on with the printer here, but I know it's kind of annoying. Starting to waste quite a bit of filament. Trying to mess with it here. I mean, this is the bulk of the print, really, in terms of filament, but I guess it's not that expensive. So anyway, it's kind of frustrating when the thing just completely doesn't want to work and you can't really do much about it. Like I said, brownout issues. I'm not sure. I mean, it's got about 6.5 days or so worth of printing time, I think, which really I don't think that's all that much for a printer. The printer's about a year old, a little over a year old, I suppose, at this point. It's actually about a year and 5 months, almost a year and a half old. But anyway, it's, I don't know, just randomly stopping and doing weird things. And the other thing that I noticed with that printer is that it was inside of the Repetier host software, just looking through the log file, or whatever that is, a little log thing down at the bottom of the screen. There's an error message about not being able to initialize the SD card, and sure enough, looking at the SD card tab, it's everything on it's grayed out, and the card is actually still in it. So I don't really know what's going on with this thing. It's being a pain in the butt. Anyway, it's not being very nice to me. So anyway, at least I got this part done, which was the easy part, and that's why I did it first. But I guess the only, like I was saying, that seemed like power supply issues, brownout, no power. I'm getting 120 volts into the power supply. I'm getting about 13.2 out of it, which I've had it set up at 13.2 for quite some time, and the reason why I set it that high was because the heated bed just wasn't really getting the kind of power that it needed in order to maintain any kind of decent temperature for ABS. So I think out of the factory it was at 12.2 volts, and I turned it up to like that 13.2 back like 6 months ago or something like that. It was quite a while ago I turned it up to 13.2, and that actually helped out quite a bit with that. So I don't know, you can tell it's just kind of a cheap power supply, or at least seems like a cheap power supply. I don't know really how good it is, but it doesn't seem to be it seems like it's putting out current. That's why I don't understand why I'm getting brownout errors. Also, it's getting voltage up there. All the connections are tight and whatnot, so I guess may take some experimenting to find out what's going on with it. But I'm not going to mess with it till tomorrow, so. Anyway, transmitter unit is done. Go hook it up and make sure it still works, and I'll start messing with that printer tomorrow and see if I can't get it to do something. Alright, you'll have to excuse all the background noise here, but I have found a potential issue here that I'm not real sure is the problem, but it could be a problem. This heatsink underneath my finger is actually a voltage regulator, and the terminal block in front of that is the power input. So the voltage regulator is powered right off of this. So I turned up the voltage on this thing, right? So with this voltage up at about 13.2, that could have actually caused that regulator to start to overheat, and therefore drop the voltage down, or brown out basically. But I'm not really ruling out the possibility of there being some other issue besides a brownout error. One thing that I'm actually going to do here, this little trick I kind of thought would work, and I just checked it with my multimeter and it does. I can actually just hook up wires to these in-stop switch connectors and get the 5 volts on them and measure the 5 volt rail. And the reason why that works is one of these is connected straight to ground, and one of these is connected to a resistor up to the 5 volt line, and then that goes into the microcontroller over here. So anyway, what I'm actually going to do is go get the oscilloscope out, and I'm going to put one probe of the scope on the 5 volt rail, which I'm just going to hook up off of these since it seems to work just fine. And I'll put one on the power supply and see what happens here. Right now I've got the voltage turned down a bit, down at 12.7 volts instead of the 13.2 that it was at. So we'll see what happens here. It's probably going to take forever to get this bed to heat up to a reasonable temperature, but we'll see what we can get. Alright, so I'll go ahead and explain what I have set up here and what I've got going on. Right now I have started printing again, But I've added in a fan over here just to blow across those heat sinks, which actually seems to be keeping them quite a bit cooler than they were, so hopefully that helps out. I've still got the oscilloscope hooked up. The top one is the 5-volt rail, the bottom one is the 12 volts off the power supply. And basically what this is it's looking to see if that entire waveform fits within that little gap in the yellow spot. So that's the mask, and this is pass-fail testing, so if it drops below that, which is about 4 volts, it will stop the scope and keep that waveform on there, which is actually pretty useful because it's gone off quite a few times actually already before I put that fan on there. And the last time it is when I actually started printing, because the motors took a big spike of current there, but right now it seems pretty stable, so if something does happen I will see it on this in terms of voltages. So I'm thinking adding that fan will actually help here, so we'll see what happens here. Alright, so this is the finished product. This thing warped quite a bit. I'm pretty sure it's just because I didn't have the nozzle quite close enough to the bed. But anyway, it warped up pretty bad. It could also be because I turned the voltage of the power supply back down, and that caused it to not be able to regulate the bed temperature quite as well as it was doing. So, then bust the support piece out of here and see if this will actually fit in here, which I always have my doubts with these things. So first off, looks like that switch hole is going to be too small. Maybe not. There we go. And the hope being that all these holes actually line up to USB ports and things. Now this I can move around in here and just glue wherever. That's kind of off. I might have to do some work to that in order to be able to align that. But that's actually not too bad. Not sure how that got so far off though, because this one just is flapping around in here. I don't have it secured to anything, so that I can move. The switch of course lines up because that also moves around. Still turns on. Should get a signal, theoretically. It might not. I don't know. Sometimes it does, sometimes it doesn't. Usually once I turn the camera on, it quits getting a signal. I've noticed that. Oh yeah, we're still getting a signal, 13.04, which is actually kind of low. I'm not sure why. I wonder if something's not hooked up right out there, but... Alright, so I've got it filed away, at least to the point where I can come in here, plug this in. like so. And the bottom one, I'm going to have to secure that charging port because that's only soldered on there by one little piece of wire. So I'm going to have to secure that in there before I try to plug it in. And then the only thing left to do will be to screw the switch in place. And that'll be pretty much it with this. I'll have to show you the code stuff. I'd probably secure this battery down underneath this board too. But anyhow, seems like it'll work fairly well. The Arduino Nano kind of tilted a little bit when I plugged that USB connector in, but it's close enough. And this kind of demonstrates a big reason why I wanted to put headers on everything, and that's so that I could take this off without having to unglue all this stuff, and I can take the circuit board out and stuff like that. Then all I gotta do is plug it back in. So anyway, take that off real easy if I need to service anything in here. So I'm just gonna glue this board down. I'm gonna glue the battery to the back of it, stick it inside there. I'll screw the nut on the switch, and that'll be about it for this project. So let's see here. Glue gun probably isn't warm enough to do this yet. Maybe it will be. Using glue everywhere. So put it to use. Alright. Still oozing glue a little bit. Tack this side down or something. Probably have to glue the top on the case too. This will just go in here like so. I'll put this on first, I suppose. Might not have to, I guess. I have to get that switch screwed in, so I guess I better wait to put that on. So let's see, this nut is not in the right spot. Alright, so still working good here. I got everything mounted properly except for the lid, so run a bead of glue down here and a bead of glue down this side. I don't get it on everything, geez. Alright, so I've taken the label maker here and made a couple of labels. I don't think I need to label what's on and what's off on the switch, because that's going to be pretty obvious, because when it's here it's off, and when it's like that it's on. Anyway, now that the noise is gone, we'll go ahead and put on the program and charge labels, because I have two different USB ports that are exactly the same, so probably a good idea to label what's what. I've got this clear plastic stuff. I'm not sure how well it's going to show up. Alright, so this is about it for part 2. In part 3, I'm going to go ahead and take a look at the code, and I'll give my final impressions on this. Now, the reason why I want to wait to do part 3 is A, this has actually already taken me like 3 days to complete. Kind of completely ridiculous amount of time on this one. And also, the code is going to take a while to go through. And I'm not done with the code yet. I still have some more tweaking to do with it. So anyhow, that's it for part 2 of this. Hopefully you enjoyed it. And I'll see you next time, guys. Bye.